Well, today we will be doing part 1 of section 0.2, Ordering Numbers. The objectives of this section are to understand inequality notation, order real numbers using inequality notation, including fractions and decimals, translate words into inequalities. Section 1, Inequalities. Definition 1. For two real numbers a and b, we say that a is less than b if a is located to the left of b on the number line, written a less than b. A is greater than b if a is located to the right of b on the number line, written a greater than b. Now I know students have trouble remembering which one's less than and which one's greater than with the symbols. And some of you have learned like the alligator eats the bigger one. The one that works better for me is the arrow points to the smaller number. So since a is smaller, it points towards a. Since a is bigger, it points towards b. Just a nice little hint to try to remember them. Then a is equal to b if a is located at the same point as b on the number line, written a equals b. The symbol equals is called an equality, where less than and greater than are referred to as inequalities. So for less than, it would look something like this. You have a to the left of b. So a is less than b. For greater than, you have b to the left of a. So a is greater than b. And then for equal to, they're located at the same spot. So since they're located at the same spot, you can't draw two separate points. So I'm going to write a on top, b on the bottom, and this is when a equals b. In addition to less than and greater than, there are three additional inequality symbols used to compare numbers. Less than or equal to, so it's the less than sign combined with half of the equal to sign. Greater than or equal to, so again, it's the greater than sign combined with half of the equal to sign. And not equal to is the equal to sign with a slash through it. Example 2. Determine if the following statements are true. If false, provide a true relationship between the two numbers. Negative 8 greater than or equal to 4. Well, that's false because all negative numbers are smaller than positive numbers. So a true statement would be negative 8 is less than 4. 0.7 less than or equal to 2. Well, that is true. And then 3 over 3, is that greater than or equal to 1? Well, you can reduce 3 over 3, which is 1. Is 1 greater than or equal to 1? Yes, that is true. Because of the or equal to part of the inequality. Translating words to inequalities. When solving application problems, it is important to be able to translate verbal statements into mathematical ones. The following table helps us keep things in order. So, for the less than inequality, you can have less than, or you could also have smaller than. A sample word statement would be 3 is smaller than 5. In symbols, it would be written like this. For greater than, you can have is more than or is greater than. For example, 9 is greater than -1. Then in symbols, it would look like this. Now, less than or equal to has a few more ways of writing it than the previous two inequalities. For example, it can just be less than or equal to. More commonly, though, it'll be no more than. So notice, even though I'm using the words more than because I'm putting the word no in front of it, that will make it less than or equal to, saying I'm not allowed to be bigger than. Same with if we use the terminology at most. So 4 is less than or equal to 7, or equivalently, you could say 7 is no more than 9. Then for greater than or equal to, you have greater than or equal to, at least instead of at most, and no less than instead of no more than. So 10 is at least 5. In symbols, 10, sorry about that, greater than or equal to 5. Then for the not equal to symbol, you can say not equal to or different from. -2 is different from 2. In symbols, -2 is not equal to 2. And that is it for part 1 of section 0.2.